Lesson 2.3.2, using linear combination to solve a systems of linear equations. In this video, we will solve systems of equations using linear combinations methods. What do you call a wolf that is very conscientious of his surroundings? A werewolf. All right, the steps for linear combinations, or I like to call it elimination, and we'll talk about that later. I'm not going to read through these steps this time. I'll just show you the steps and I'll label them as I go through the problem. Solve each system of equations using linear combinations method. So the first step is to write both equations in standard form, which is already done for us on question 1 here. Okay. The second step is to multiply one or both equations by a constant to obtain coefficients that are the same but opposite signs. Well, we're looking at x or y and we want them to be the same but with opposite signs. So if I look at x, it's already done. So really we don't even have to do that step. So we're going to go to step 3, and step 3 is to go ahead and add the two equations together. Okay, so we're going to take negative x plus x, and that cancels. We're going to take 2 plus 6 and get 8y. And we're going to take negative 8 plus negative 16 and get negative 24. So that's our step 3. Then we're going to go ahead and divide both sides by 8. And so we get y equals negative 3. Okay, so step 3 is to add them and solve for whatever's left. Then we're going to take this and plug it back into one of the two original equations. Whoops. So to make things easier, we'll go ahead and use the second equation. Why? Because x is already positive there. So that'll make things a little easier. Doesn't actually matter which one you use. Both of them will work out. Oops, if I write the problem correct, that's negative 16. So then we're going to add 18 to both sides, and we're going to find that x equals 2. Okay, so that was step 4. And then step 5 is just to write our answer as an ordered pair. So 2, negative 3. And then to prove my point that it doesn't matter which equation you plug it into, I'm just going to quickly show you plugging it into the first equation. So you have x plus 2 times negative 3 equals negative 8. So we get negative x minus 6 equals negative 8. So we get negative x equals negative 2, and we divide by negative 1, and we get x equals 2, and it works out, and they're the same. So it doesn't matter which equation you use, they both get you the same answer. That being said, I tend to choose the smaller numbers when I work with the equations, or having non-negatives if I can manage it. All right, what I'd like you to do now is try number 2 on your own. All right, so hopefully you realized that the x's were already negative, just like the last one. So all you had to do is add the two equations together. And in doing that, y plus y is 2y. 5 and 9 add up to 14. Then we go ahead and solve for y by dividing by 2. And you get y equals 7. Then we take the 7 and we plug it into one of these two equations. And just like last time, I picked the one equation that did not have the negative in it and solved that one. Oops. Then I went and erased things that I shouldn't have. Okay, there we go. And then I solve for x, and I write my ordered pair x and y together in an ordered pair. And that's how we solve using linear combinations. And like I said, I like to call it elimination because you are eliminating one of the variables.